Cool. All right, everybody. Thank you for coming to my talk here this afternoon. Hope you're having a wonderful time here at AppSecUSA in wonderful San Francisco. Today I'm going to talk to you about, of all things, TLS. So my talk is entitled Ciphertext Says Something, presumably. I don't know. That's the point, kind of, right? And what I'm really trying to get at today is that, you know, enabling PKI, TLS, and organizations is really, really not fun, right? And as security professionals, we should do as much as we can to kind of make that easier for everyone involved in an organization. So I'm gonna kind of frame this in a light that we all can kind of relate to, right? OpenSSL generally, from a command line point of view, is terrible, right? Quick show of hands, who knows what these do? Like all of them. Like you're better than I am because I have no idea, right? I have some idea. But more often than not, you know, you have the three possible outcomes, right? Like you may know all of these. You may rely on your cheat sheet, like maybe you had the command that worked one time, you wrote it down, you're like, I'm gonna use this from now on. Maybe you Google it, right? But none of these are kind of what you really want to do when you're thinking about security. You're thinking about like kind of having a robust, repeatable kind of practice. We all kind of think about that when we do security. And Googling it isn't a viable option really, right? And I would say that, you know, for the few of us in here that do know all these commands, that's awesome, but you know, we're kind of speaking to the choir here, right? So as security experts, we may be kind of responsible to know these commands, know how they work, the inner workings, know what the pitfalls of some of these commands do and some of the pitfalls of PKI. But for a normal everyday developer, you can't really expect them to know these commands, know the ins and outs. And if it's hard for us, it's hard for all of us to know what these are. The expectation on the developer is just too high, right? To get them to use these commands on an everyday basis. And I love that, you know, OpenSSL, like this command just outlines the problems with it, right? You ask for help, and it's like, I don't know. Here's all the possibilities, right? That's not helpful. It's just, I just sigh every time I see that. So a quick little bit about me, once I kind of frame the general problem. I'm a cloud security engineer at Netflix. I work on the security tools and operations team, and our charter is really to, you know, make tools for security to enable developers to be more secure when they go about deploying their applications. I love writing things in Python, all things kind of security automation, big avid mountain biker. I'm a pizza expert, if you don't believe me. LinkedIn says so that must be true. Previously, I've worked at larger organizations. I used to work at JP Morgan as an incident responder on their incident response team, and I also worked on their cyber intelligence teams. So now that you know a little about me, you know a little about the problem, we kind of start to think about, well, all right, well, why are we here today? Why did I start thinking about this problem? Why did you know, this problem of these commands kind of come to a highlight in our everyday process, right? And I can point to the exact time when that happened, when I started to think about this way too much, and that was essentially Heartbleed. So for those of you who don't know, Heartbleed was a vulnerability that was discovered, released, what have you, in April 2014. And essentially that vulnerability was in the OpenSSL stack that would potentially allow an attacker to uncover the private keys on any given server, right? Essentially, this impacted all of our different front services, internet-wide, right? This is all hands-on-deck kind of drill. And what matters worse about this particular vulnerability is that there wasn't a really good indicator that you've been compromised, right? So without that, we kind of had to assume the worst possible case had happened, that all of our keys were exposed, and that we were going to have to reissue all of our SSL certificates. So I have a couple questions up here, and these are kind of my like Dante circles of hell as I kind of grasp the realization of what we were going to have to do when Heartbleed kind of came out, right? So the first question is like, well, okay, where are these certificates stored? And the answer is we didn't really know, right? So we didn't have very good visibility into whether they're deployed on instances, whether they're deployed in different accounts, whether they'd been given to third parties. We know there were some references of these certificates, but we didn't really know very much about them. The existing kind of process for getting these certificates is probably something you're all pretty familiar with, right? So it had been organically grown, one-off requests. You know, these things get issued over years and years, and those people leave the company who requested them, who issued these certificates. It's all very fuzzy in the kind of auditing perspective. We also didn't really know, or we had a good idea, but we didn't actually know how many there were, right? So in our case, there were hundreds of these certificates. For a lot of small organizations, maybe you only have one or two top-level domains you really care about, and maybe it's not such a big deal. But for us, for those who don't know, Netflix, you know, seems like a very nice API. You get your good user experience, but behind that is actually hundreds of smaller services to kind of make up that experience, and that, along with internal applications, partner portals, and all of these things had SSL certificates issued in the years. So there were actually quite a lot of certificates that we kind of had to first identify the universe of, and then go about trying to remediate this. And another key kind of thing we didn't really understand, so typically what we try to do is we partner very close with our application developers. And when we try to identify these certificates, we didn't really know who owned them, right? So we can kind of deduce that this domain name kind of belongs to this app, but which team owns that app? That app could have been created a long time ago. We don't know who the current owners is. Applications change hands between teams. Names change a lot, right? And people come and go. So we didn't have a good lineage or story around who actually owned these applications, and when we go and make this change, who we could contact to give a heads up, be like, hey, this shouldn't impact your service, but we should still notify you that we're making a change that could potentially impact you, and you should be aware of it. And then we had another question too, is that you kind of discover these certificates, you don't really know who owns them, you don't really know what the entire universe is, and then are they even used, right? So you issue these certificates, they're in your ecosystem, they may be on they could be on different instances, but you don't know if the service that they were originally issued for continues to exist today, right? So a lot of times you issue a certificate for 2 years or years. A lot of the application's lifetime just isn't that long. So maybe we need to reissue this, or maybe we don't. But we didn't really have that answer, and that was kind of really hard when you have to go reissue all the certificates. You don't know what to reissue. And then the very last part of this that was really very painful is we didn't have any existing tooling, right? So you think about the process of someone submitting a Jira, maybe they would create CSRs or what have you, and kind of do this piecemeal kind of process to getting these certificates eventually deployed to an application. But now we have to do that 100-fold. And we didn't really have tooling, and it was really painful. It was really all hands on deck process for us to kind of go ahead and quickly write up some scripting, quickly interface with some APIs. And it kind of dawned on me that, for such a sensitive task, this whole thing was broken. And it was really very painful. So, after we reissued everything, we bared down, we had all hands on deck kind of process for reissuing all these certificates. We decided to take a step back. We said, okay, well, this is obviously broken. How do we improve this process? Can we slim down this process? Is some parts even needed or not? And a lot of times when we think about security internally, we think about really providing value to the end user, in this case, the developer. And we really focus on, okay, well, we want to provide the best experience possible for them so that they come to us, that they're like, yeah, those security guys are awesome. They give us these cool tools. We totally want to integrate and use these things. And when we focus on that value, we get that kind of integration a lot, kind of talkiness, and people are just more willing to kind of come to you when you're providing real value to them. And so we really try to focus on that. We really try to focus on, if a process even needs to exist at all. We're not a big process company. We don't try to enforce a lot of rules on people, because we find that, generally speaking, if you make something easy, if you make something, useful to someone, they'll seek you out, right? And that was obviously not the case for our existing tool set. And then we try to think about, in this case specifically, what does a paved road look like for HTTPS? So what from a developer point of view, what do they have to go through to get their application up on TLS stack? What kind of processes, what kind of requests do they have to make in order to just flip that switch on their application? And how do we make that paved road as obvious and as short as possible for the developers? And then as a side benefit to all this, how do we reduce our pain? We're a relatively small security team. We like it that way. We like to kind of force multiply ourselves as engineers through automation. And at the end of the day, I don't think anyone really wants to sit and go through tickets or copy and paste requests and stuff through different CRMs or anything like that. So how do we reduce our pain and our developers' pain through tooling? So let's look at the kind of old way, right? So this is probably very familiar to all of you who've ever issued a certificate, right? So the very first step is you have to generate a private key. You have to use those OpenSSL commands to generate this very sensitive piece of information to kind of facilitate this whole process, right? And the problem with that is sometimes developers don't understand the context of what private means, right? So you can say, yes, go to this, in the best case scenario, say you have an internal Confluence that tells them all the right commands to use, they follow that to the step, but they don't typically understand what private means in this context. And at the end of the day, it's not really fair to kind of expect them to know that in a lot of times, right? So what we would see happen is they would, go through this whole process, they generate these private keys, something would go wrong inevitably, right? And they would email me the private key, right? And then you're just like, all right, well, now we got to do this again because that's broken, right? And that's not a good experience for them. It's not a good experience for me. And it's just not fair to have them understand the context of what private means, because they're used to like having logs. Like, you have a problem, you submit the stack trace to somebody, right? And that same kind of context doesn't really apply to this process in particular. In addition to that, when you have developers kind of issue these commands on their laptops, those keys are on their laptops. Do you know what else is on that laptop? Because I don't know what's on that laptop. And if they don't understand like operational security, they don't understand, like, if they email keys to me, like the security, who's to say they wouldn't email it to all their 10 buddies, Giving them that access, like the access on their laptops, was just not a good kind of methodology for us, and we really wanted to cut that exposure out of the whole process. And then the next step, generate a CSR. Again, maybe the best case scenario is that you have a Confluence that tells them how to fill out that questionnaire. But a lot of times, if they do one thing wrong, it's going to be rejected by the CA, and you're going to have to do the whole process over again. And that's not really on their fault, right? Like, that they abbreviated the state instead of spelling out California. Like, that's just a weird CSR thing. Why would you expect a developer to know that kind of thing? And why would you require them to kind of ensure that that's correct? So they would, generate private key, create a CSR, submit it to a certificate authority. In our case, that was a kind of a partner portal with our CA. They would take their CA or the CSR, if they create it correctly, submit it to the authority. Essentially, it would go into a queue, and then they would essentially email the security team or file a JIRA and say, hey, can you go approve this? And as this process, we're kind of small. We pride ourselves on responding to our developers really quickly, but inevitably it slows them down. And anything you do to kind of slow the developer down is something they're going to try to avoid. So this process of getting permission to have these certificates created didn't really make a lot of sense to us. Because when we looked back and we looked at the JIRAs, we looked at the evaluations, essentially we were going that we would never deny an application unless it was like terrible, like they wanted a certificate for Netflix.com or something. Obviously you don't need that, right? But all in all, we would never really add any value to this process. It was mostly rubber stamping. And it was creating work for us, and it was creating frustration for them, and it just wasn't working out really well. So they would go through this process. It was approved. We would go ahead and approve it. Hopefully everything went correctly. Hopefully at the end of this, they didn't end up saying, oh, we need to deploy it on a server, and we don't know how it works, use a private key. Because then you gotta go do the whole thing again. And that's just like more pain on more pain. So all of this was just super frustrating for both of us as a security team, for the developer. And then in the day, you had this kind of distributed pieces of information, right? You had the developer creating the private key. You had the certificate authority creating a public key. They would take those pieces of information, deploy them on some server that you may not know about. And essentially, these keys, these very sensitive and important pieces of information to your infrastructure, you would have zero visibility in, right? They're on a developer's laptop. You don't know where they go after that. You don't actually know where these certificates are deployed. And all this kind of manifests itself when we went to reissue all these certificates with Heartbleed and kind of really brought to bear how painful this was for everybody. So today, we have Lemur. So Lemur is our orchestration management that we wrote to kind of address all of these problems. It gives you the ability to manage certificates, orchestrate them between different environments, and essentially just have control and auditability over those very sensitive pieces of information that, you know, we're on a developer's laptops, we're in a Confluence page, we're very distributed throughout an organization, and now they're centralized and they can be tracked and kind of managed in a correct and secure kind of process. So let's look at the new way. This is pretty money, right? So log into Lemur, select your certificate authority, you get a certificate. Excellent. They don't need to deal with OpenSSL commands. They don't need to deal with, oh, is my intermediate correct or not? Lemur takes care of that for them correctly, right? So they don't have to deal. They don't need to know the particularities because the defaults in Lemur take care of that for you, right? So you think about, oh, I want all my new certificates to be SHA-2. I want all my keys to be 2048. Developer no longer needs to know what those words even mean, right? So because I'm going to do it for him. And essentially, you can see that there's no process of approval. For us, we decided that we kind of have a mantra of, you know, we're all adults here, and it was much better for us to speed up the orchestration and deployment process for the end developer, and then just get notifications of things happening to have auditability, to have, in case something went wrong or something was issued incorrectly, we as a security team could take on that notification and action it if need be, but for the 99%, we don't have to do anything, right? We can get out of the way. We don't have to stand in the middle of this process that we weren't adding value to. All this kind of, these defaults, they all provide a kind of, and essentially all they do is essentially make it really hard to make the common mistakes that you see in developers. You know, when you have a developer kind of going out to Google to generate a private key, do you know they're not going to hit on a website from 1997 and generate a 512 key? No, I don't know. They find weird things all the time. But essentially, those common mistakes, those defaults, really kind of cleans up the whole process and makes it a lot faster. We also have kind of this idea of, you know, as we build out this UI, we build out this tooling that if there is a mistake, if something in the process goes wrong, it's probably a fault not on the developer, but on our tooling, right? So we look at that failure as our failure, and how can we improve that process for the developer, and how can we make it more secure? And I think that's a really important kind of note to take when you are developing tools for internal kind of developers. it's not that they messed up. It's that either you didn't provide the right context, or just something in the way that the process is not good enough currently. Another thing that this does for us is by providing this automation, these tooling, it creates a really good relationship with the developer, and it gets them to trust us, right? So they can kind of, if they can have the feeling that they can go here, they can get their job done, it's gonna work, it's gonna be reliable. That relationship, that trust through automation and tooling is really critical for our success as a team. We really strive to have that really good relationship with developing teams so that they come to us. So if they do have a use case that's maybe not in the 90%, they'll come to us first, they'll ask for suggestions. We can either help them by building more automation for their use case, or we can guide them in the correct way. But what we don't want to have is we don't want to make their lives difficult so that they avoid us at all costs. And I think that's kind of the whole kind of security DevOps methodology. So, how does Lemur do all this? When we thought about our users and their needs, we want to make sure that Lemur was as flexible as possible. So our developers love to try out new things. They crave new technologies, either from AWS or from third parties, and we wanted to make it such that we could provide them that flexibility with minimal changes or adjustments on our end, right? So Lemur is largely built around this kind of plugin architecture. The idea being that you can accommodate new tools, new CAs, new different technologies quite easily, and give them what they essentially want, right? And still maintaining that kind of orchestration and secure abilities within Lemur itself. And the way we do that is a couple different entry points into Lemur itself. The first one I'm going to talk about is probably the most, maybe not the most important, but definitely the most useful. And that is the ability to essentially reach out to third-party CAs. So I want to make it a point that Lemur itself does not generate certificates, right? It relies on plugins and third parties to actually issue those certificates. We felt that it was very important to kind of separate out those two parts of our infrastructure, such that segmentation of your services via smaller services reduces risk. No longer do we have to worry about very, very sensitive root keys on the box that we're issuing certificates and orchestrating them. And it allows us to be kind of vendor agnostic, right? So we happen to use VeriSign for a variety of reasons, but there's no reason that Lemur couldn't issue plugins from Digicert or EJBC or whatever you have internally can be plugged in essentially to Lemur, and you get all the benefits by providing a very small piece of integration code that if you're really lucky, you have a provider that has a JSON API. If you're not so lucky, it's going to be much longer integration code, but that's really up to kind of who you're using. But then, in the very basic sense, this is all you would need to kind of integrate with Lemur. These two kind of definitions to provide Lemur with certificates and let it handle all of the kind of benefits and orchestration you get from that entry point. So the plugins, it's important to note that Lemur will create the private keys and CSRs for you. But if for whatever reason your API, your provider doesn't take CSRs, maybe they take some JSON attributes, all the kind of full-fledged options and stuff get passed down directly to your issuer plugin. So you can kind of go ahead and create those certificates if they have peculiar properties. So that's important to note. So hopefully it gives you all the information you would ever need to generate a certificate from any of the providing CAs that anyone may need. Another really important integration point we have is Lemur will do expiration notifications, right? So the idea is that this is a central portal for all your certificates. you're issuing from one or more internal CAs, external CAs, it should know about all the certificates that you issue. And because of that, it's a great entry point to notify on those certificates if they're expiring, if you wanted to audit them for SHA-1 versus SHA-2, or if you wanted to audit your kind of private key distribution. And the way we do that is essentially the email plugin. So it's the current one we currently write. It'll notify us on a daily basis, and it's all user definable. So we have a lot of teams with different internal needs, and we wanted to make sure that this was plugin focused as well, so that if a team decided, hey, email doesn't really work for us, we want HipChat notifications. All right, cool, we can give you HipChat notifications. Or for whatever reason, if you want to have an SNS text message. The idea is that because there's going to be different needs, the integration that they need to write is very compact and very kind of separated from the core of Lemur itself. Of course, for all these notifications, by default, Lemur will do the right thing and notify the security teams. Oftentimes, we simply CC ourselves on all of these kind of notifications because ultimately, while the developers themselves own these applications, we want to be involved in that conversation. If for whatever reason they aren't responding, they're not kind of up to date on what needs to be done. If that becomes the case, we can always step in and make sure that the certificate's lifecycle process is kind of completed. But at the end of the day, these all get sent to the people who created and own the certificate. So in the ideal world, if developers are on top of their game, on top of their applications, we don't really look at these notifications. They would just go ahead and do what they need to do, be either reissue the certificate, mark the certificate as inactive. Marking as inactive means that they won't get notifications anymore, so it's been deprecated, or the application is just, or that certificate's no longer been used. And we allow them to define the time frame, which is really critical for some teams. Some teams have really, really fast response time, so maybe a week before they can go ahead and push out new certificates. Other teams are a lot slower in their kind of development life cycle and the way they kind of do things and push stuff out, so they may need longer notifications. And we'll allow them to kind of specify what their tolerance is for notifications. And the last kind of entry point or plugin point is this idea of sources and destinations, right? So as good as Lemur is, we realize that there's going to be certificates in our environment that weren't issued through Lemur, right? So you think about third-party integrations, so that maybe they give you a certificate that you're going to use to communicate with their service or their API. There's no reason why Lemur shouldn't be aware of that, shouldn't be able to track that alongside all the other certificates in your environment. So Lemur allows you to upload those certificates. It also allows this idea of a source. So in our initial kind of outline there, we had an idea that all these certificates were in our AWS accounts, and we really wanted to pull them all in, and we wanted to make sure that Lemur is tracking all of them. So it comes with this ability to essentially query all of your AWS accounts or all of your whatever source you define and pull in all those certificates so that Lemur's tracking them. It's giving expiration. It's telling you what the life cycle of those things are. And we hope that, as kind of other people have other use cases, other environments that maybe we haven't thought about, that writing a plugin to kind of go ahead and evaluate your whole environment to give you a really good view of the certificates that you have, that they can write other sources to kind of pull that information in and track that. The other half of that is, so once you kind of define these sources, pull them in, it makes logical sense that you're also going to need to deploy these at some point, right? So you think about how certificates are typically deployed. Unfortunately, some of them are checked into source code. They're deployed on instances that maybe they're managed via like a Puppet or a Chef kind of distribution service. And with destinations, we wanted to make that as easy as possible for the developer, right? So our end goal is essentially that those private pieces of information, those private keys, those public certs, those intermediates, the developer shouldn't ideally need to know what those are, right? So with destinations, what we do is take those pieces of information and we upload them directly to AWS, to the ELBs that need them. And by doing this, by saying, okay, well, I'm a developer, I'm deployed with an ELB, I need to deploy into this region. Okay, when they create the certificate, you can also say, oh, I also need it in this account. Once it's created, it'll go ahead and upload it, and it's immediately available for you. You never have to see the private key. You never have to touch that piece of information. And that ability to reduce copying and pasting between source code, between different interfaces like web apps or from the partner portal or even from the email onto instances I think is a huge, huge benefit to kind of this orchestration of certificates. And what it also allows us to do, and what we hope to really push in the future, is that now we have some tooling in place to do this kind of orchestrations that we want to speed it up, right? So we want to say, okay, the developer is creating a new application, they can go through this process, but what happens when they need to reissue that certificate in a year or 2 years? We want to be able to essentially say, okay, we already have the tooling in place, let's go ahead and reissue that certificate for that developer and redeploy it for them without them knowing, without them caring, right? And that's ideally what we want. And that kind of tooling and kind of automation allows us to kind of codify this whole process, right? So it's in code. No longer are humans copying, pasting, messing things up, emailing these things to ourselves. And the speed and we essentially let computers do what they're really good at, is the same tasks over and over again, which humans unfortunately aren't great at. So I want to talk a little bit about what it means when we say kind of CA agnostic, right? For us, that means essentially that internal certificates shouldn't be issued in a different way than external certificates to the end developer. They may have different use cases, and we kind of go through some knowledge of when to use what, but essentially it should be the same interface, it should be the same API, because they're all just certificates. There's nothing inherently different from them other than who issued them. So our internal CA is called CloudCA. It's a kind of API-driven certificate authority, and we fully have integrated it with Lemur. So essentially what we allow developers to do, we allow them to create very, very lean CAs for their applications underneath our internal CA. This is particularly useful when you want to do mutual SL. You think about, okay, the normal server-client relationship. You have a browser, you have a server. They do the one-way TLS handshake. But in the cloud, you often have a lot of different, these hundreds of services and inter-service communication. And sometimes it's very, very beneficial to have TLS communication between those services. And CloudCA really allows us to do that. It allows us to kind of create very lean certificate hierarchies. So instead of trusting every CA under the sun, as most OSs do at the current moment, you can strip down your trust hierarchy to what you really need to talk to, right? So if you know that these two services are only going to talk to each other over TLS, they'll never talk to anybody else, you can reduce a lot of that trust and make that relationship much more secure. Unfortunately, we don't have current plans to open source CloudCA, just a resource restriction. But you know, maybe someday in the future that we would do that. So one of the key things I want to point out about Lemur is that for all of our internal apps, this is kind of the same idea, is that we are very, very API driven internally. So you think about Netflix, you think about the nice experience, you think about all the hundreds of services that go on behind the scenes to give you that service, they're all communicating via API. And when we designed Lemur, we thought it should be no different, right? It should be API driven. So Lemur is actually just an API with the Angular on top of it, right? So anything you can do via the UI can be done via the API, right? And we wanted to do that so you could essentially dog food your own API, right? So some APIs I've used, I don't think the developer who wrote it has ever used the API itself, because if he had, like, he would hate himself, right? So I think it's very important that, you know, we kind of have this methodology where you put the API first and then you build applications around it. Another great benefit of that is it allows us to kind of scale this, right? So yeah, it would be really nice if we had this good UI, this good web portal that would do all these things for you. But then you have use cases where, okay, well, I have a specific service that needs to issue a lot of certificates. How do I enable that, right? If it's only a UI-driven application, I can't necessarily do that. But with an API, it's great. I can be like, all right, sweet, here's your authentication. Go hit it as many times as you want, and make that integration just super, super smooth. And there's no pesky humans to mess stuff up, right? Computers are pretty good at talking to each other. So all this kind of automation, all these tooling, kind of leads me to push an initiative inside Netflix of not only enabling SSL on all of the applications that we run internally and externally, but the idea is that with the process so easy, right, there should be no reason why a developer wouldn't put SSL on his website, right? You make that bar so low that you make it almost the default. And that's really what we want to do. We want to make sure that, you know, that's the easiest course of action. And we also want this tooling, we want to kind of enforce the iteration process to be quicker. You think about how certificates kind of issued today, you issue them for 1 or 2 years. The problems we kind of see is that, you know, after 1 or 2 years, nobody really knows, A, how to do it again, or B, like what the process of creating a new certificate is now, right? Things change over time. And the idea with this automation, this tooling, making it very, very easy, making stuff like auto-renew work, is that we want to do this more in step with the actual development process that our applications is being deployed. There's no real reason why a certificate, which is a piece of infrastructure, shouldn't be able to be deployed as quickly and as easily as an instance or an ELB. And that's already something the developers are comfortable with, right? So it kind of makes sense to them that they can go ahead and do this, right? It's not some like big red button that they have to do every 1 to 2 years that they have no idea how to do. It's just becomes a normal part of their routine, and they become much more comfortable with it. And I think that's a great win to kind of increase the iteration process. When you do that, you can shorten expiration of certificates. You can reduce risk in a variety of ways. And I think it's just overall better to codify that process. So a couple key wins. So with Lemur, you get centralized notifications, right? So Lemur will not only issue all of your certificates, you can import ones you get from third parties. You can say, go out and look in my environment, go look in my source code, go look in the variety of vendors that I use. Go ahead and pull those certificates in. I want to track them just the way I would any other certificate and get notifications on them. We get direct ownership, right? So Lemur is integrated into our own internal SSO. So when a developer creates a certificate, they get attached to that certificate whether they want it or not, right? It's part of their identity. And then we also allow them to attach an ownership team DL onto each certificates. So in the case of, you know, they've moved on or the teams have changed a little bit, they can transfer ownership of that certificate just as they would maybe an application. And that's really beneficial for us. In the event of another Heartbleed-like scenario, we have a really good record of, okay, these are certificates we have, these are what we need, these are who we need to talk to when we eventually flip the switch, right? You get great deployment and visibility. No longer are you up at night being like, oh, I wonder what certificate's going to expire, right? So it helps with that, right? When you have an idea of what the universe of certificates you are, it really helps with those kind of anxiety fears of what's lurking behind the next corner and what's going to happen. Lemur also has the ability to do role-based access control. So if there are different certificates or teams, you can limit access to who has what, right? So obviously, if a team issues a certificate, they should be able to see the private key for the certificate if they need to. but everybody else should not be able to. And Lemur provides that kind of separation between teams. It also provides separation of, say you have multiple internal CAs. Obviously, if a team stands up their own CA, you shouldn't allow everybody to issue certificates off of that. And then the last one is kind of near to my heart. Essentially, what I've learned from kind of interfacing with a lot of vendor APIs is that it's not fun, right? So not only are they're very slow moving at times to fix bugs, they're not entirely straightforward. So I think a key win for Lemur is providing that abstraction away from these third parties, right? So if a developer comes to me and they say, okay, well, my service will need to issue certificates, I can say, okay, we'll use this API. Don't worry about the 10 other vendors behind it. I can abstract that away from you, and you only have to care about one thing, right? There's not much value in telling a developer you need to go learn these 10 vendor APIs in case you might need to use them. And Lemur provides a kind of common interface or gateway for all of our certificates internally. So they really like that. Cool. So this Monday, we open source Lemur. Go check it out. Contribute. See if it's going to work in your organization. There's pretty good docs. I think I've had 4 or 5 pull requests for my grammar. So if you find any, I'm not a great speller. Yeah, that's kind of it. Now, do you guys have questions? Sure. Do you just want to go up to the mic, or you can yell it out? It doesn't matter.
You didn't really go into the flow actually of, for instance, how do you prove that you own the domain before signing, like that
Sure.
the CA signs it and all that?
So yeah, for us it's a little interesting, right? So essentially the main use case is Lemur is that you've already verified the domain. So almost all of our certificates are issued off of domains we have already verified. So if you think about like if you have an internal .NET domain, you would verify that domain and then allow certificates to be issued off of the subdomain. So you can issue wildcards, you can issue all those things. It doesn't have built-in kind of verification